Cool. All right, guys, we're trying something a little different. Uh, new camera, who this? It's a little weird, but I really wanted you to be able to see my hands for the science line because we are making electricity with food. Welcome. This is Science Online. My name is Chris Dorman. I work for the Maine State Library. I am the STEM librarian, and today, on the last Wednesday of the month, which means this is our last food science month, we are going to make electricity from food. So we're going to talk about a few big words. One of the biggest, and of course I have stuff everywhere right now, is you're going to need one of these. So this is not just any nail. This is a specific nail. It's called a galvanized nail. And basically what that means is it has either been dipped or plated in something called zinc. Zinc is really important to this. Now, not all nails are galvanized, so make sure that the nail you have is galvanized. You also need copper wire. I found my copper wire. Obviously, I keep everything because I like to reuse it, and I'm a huge recycler. So I had an old fan cord lying around, old fan actually. So I cut off the cord, broke it into two cords, and then I did what is called stripping the ends. So I took the insulated white rubber off the ends and then just twisted them, and now I have copper wire. Okay, so those are the two big things you really need. You need something that is galvanized because it has to have zinc in it. And you need something that is copper because that's how we're going to create a chemical reaction, and that chemical reaction is going to create electricity, which is going to run our clock. Now, the clock I have, I actually was lucky enough. I found it is the Kids Lab Lemon clock. It was on clearance somewhere, and I was like, well, that's cool. It actually comes with zinc and copper strips. Not everybody has zinc and copper strips at home. Most people in name either have or know somebody who can get them galvanized nails and a couple pieces of copper wire. So that's why I chose to work for it. So let's get started. Let's make electricity from food. So I'm going to take you guys down. Like I said, it's a new camera, so things are a little weird. I want you to look at my desktop. Ooh, hopefully it doesn't fall over on me. And what we're going to do is our source of power today are going to be the mighty potato. There we go, the mighty potato. Okay, and as you can see, I have two galvanized nails. Now I just took my X-Acto blade, made a little hole. What we're gonna do, two galvanized nails. Ooh, that's all squeegee. In this one hole, you wanna make sure that copper is in there. Now what's gonna happen is when we connect this circuit, now remember the circuit is a circle that electricity follows, okay? So the electrodes go around in a circle, and once that circle is broken, for instance, bloop, now the circle is broken, the electricity can't flow, okay? So what we're going to do, and the chemical reaction we're going to create, is the zinc on the copper, it has some electrons. And they're kind of friends, they hang out, but copper really likes electrodes, or electrons rather. And what's going to happen is the electrons from the zinc or from our galvanized nail are going to flow or move to our copper, and they're just going to keep going. And eventually, what we will have, and I'll bring my clock in, is we are going to have this one attached here, and our positive. Oops, I don't have my copper in here. Where's my other copper? There it is. It's my other copper. Stick my other copper in here. So now we have zinc and copper in each potato. And if I've done this right, fingers crossed, I hope you guys can see my clock turned on. So again, what's happening is those electrons are moving from the molecules. So they're going from the zinc to the copper and around through. So they create a circuit, and that circuit is creating electricity. Now, electricity can come in, numerous forms. We talked about the solar and excuse me, the heat and the power. Let's see. I'm going to use my multimeter. Brandy new. I got it today. And let's see how much voltage we're getting out of our potatoes. I don't know if you guys can actually see my multimeter or not. So my multimeter says we are getting a whopping anywhere from 1.6 to 1.8 volts. Now that is not enough to hurt you. That is not enough to do anything. Uh, I don't even know if it'll make your tongue tingle. For example, so this battery, it's just a double A. I'm gonna hook it up to my multimeter, and my multimeter says a 1.25. Because if you look on all batteries, they should have somewhere on it. I don't know if I can focus in or not on that. Ooh, it got worse. 1.5 volts. And that's pretty close. I think we had what, 1.3, 1.4? Okay. So it is less, our potatoes make less power than a double A battery. But potatoes aren't the only thing that create voltage. So what we're going to do is just like before, here we go. I have taken my, oh no, you fell over. I knew that was going to happen at some point. Okay, so I have more copper wire. I've attached it to my zinc. Now, if you look here, all I have is copper to zinc because that's how it needs to go, copper to zinc. And I've just clipped it here so it'll stay because it wants to flip up on me. Inside my cups are simple lemon juice because citrus is a great conductor. And what you're going to do is I'm going to take my nail, put it in there. So now I have my zinc going to the end of my copper wire, which is connected to more zinc. And then if I take this copper wire, and once again, I connect them. And I want you to know, like, when you do this, guys, this chemical reaction actually smells. And I'm hoping I can bring it up close enough so you can see that what is happening, there's actual oxidization happening on those zinc screws. Whoop, whoop. My connection's kind of loose with this one. Can you guys see? Check it out. So once again, a battery from lemon juice. Now this also works if you stick a penny, because pennies are copper. Let's see. So this was my black for negative and red for positive. And this, our lemon juice, is not putting out 200 amps. Hold on. Oh, it smells so bad, guys. There we go. That's much better. That's still not right. Oh, because I'm not on the thing. Here we go. 1.6. So the lemon juice is actually just a little more than a double A battery. And I don't know if you guys can see this. I'll try and get in there. Now, do you see, here, I'll try and focus. Let's see, focus. Where's my focus? New camera, who dis? Do you see those bubbles forming around that galvanized screw? Now what is happening is it isn't the lemon juice that is affecting the zinc that's on that galvanized screw. That is actually the chemical reaction of the electrons flowing from the zinc to the copper. And it'll actually start to bubble hard. Well, harder. You can see the bubbles. There we go. Do you see the bubbles? They're very tiny. They're just kind of covering over the copper. And that's just because I've completed the circuit. So now every time I complete that circuit, I am moving electrons. And by moving electrons, whoop, we create power. Who knew, guys? Like, food is electricity. So now if the zombies come and you happen to be stuck in like the county with all the potatoes, you can probably light up an LED. I had a couple LEDs. I tried them. My problem is that certain LEDs take more voltage than others. All I have are green and red, and green and red are probably the worst. They take upwards of 2 volts, and the most I can make right now is, what did I say, 1.8 with my lemon juice. So if I had a white LED, I could actually power one tiny itty bitty light bulb. So this is an LED, for instance. So one tiny itty bitty light bulb. Ooh, I'm way out of focus. We'll figure out this camera stuff, I promise. Maybe I'll actually get something that isn't a tiny old 2000 era webcam on a PVC pipe, but it works for now and you guys can see my desktop, so I'll take it. So there you go. You guys are going to create electricity with food. And if you use more potatoes or you use more glasses of lime juice or more limes or more oranges, you will get a higher voltage. Just remember though, because what's happening is all of the electrons are moving from the zinc to the copper. Eventually, all of the zinc electrons will be gone. And when that happens, it's just like a dead battery. You have to go find more potatoes, guys. I hope that helps. Next month, I want you guys to know that we're going to do pressure. And I know that sounds kind of boring, but remember that if you put too much pressure in a balloon, and by pressure I mean breath. So if I blow up a balloon too much, what happens? If I take a potato and I squeeze it really, really hard, what happens to the potato? And I see Heather asked a question in the chat, does the size of the potato matter? No, it does not. These are old potatoes that were just about to grow sprouts, so that's why they were sacrificed. You can probably technically bake them or eat them if you don't want to use the food. However, it's a galvanized nail. Zinc won't hurt you. I'm just gonna take them all back and plant them, and maybe I'll grow more potatoes for this fall. But anyway, so all next month, pressure. And I'm not gonna use explosion because then you guys will think that I'm gonna do really scary stuff. And I'm not gonna say blow stuff up, but we're gonna get messy and we're gonna have fun. And I'm gonna go show you some magic tricks using pressure that's actually science. So all next month, we're gonna do pressure. And this month has been food science. And I hope you guys now understand how to make a potato battery or a lime battery or a lemon juice battery. Also, don't drink the lemon juice, guys. Like zinc has been oxidizing in it. And again, like I wish you could smell this. It's like hot, rusty metal and lemon juice, and it's really, really weird. It's got this funk, and it's either a funk from here or it's because I have my window open and Winslow is making paper and it's the mill smell. But either way, something smells funky. But yeah, electricity from foods, from fruit. Like, that's neat. Go home, try it yourself, or you are at home. We're all at home. Try it yourself, and don't be scared. Once again, try different food. Try apples. Try oranges. Try different things that you find around the house to see if you can create electricity. For those of you who don't know, this is called a multimeter. This thing right here. I got mine. You can get them for $8.99 at like Harbor Freight. They're really, really cheap. They're fun to play with. Also handy if you're a homeowner. And I think that's it, guys. Have an awesome day. If you have any questions, please put them in the chat. And I'll see you guys next week for pressure. And hopefully a better camera. Have a great day, guys.